Hi, I'm Eric Starkloff from National Instruments. I just finished my keynote at Radio Wireless Week where I talked about some of the context of what's going on in the outside world that's creating new changes to the technology in things like 5G. So it's really the move from connecting places to connecting people, and now it's about connecting things and connecting the next 50 billion devices. And this is causing major changes in wireless technology that's not just serving higher bandwidth, but also a massive number of devices and high reliability. What I showed in my keynote was a platform of hardware and software that can be used to go all the way from early stage research and prototyping through verification, validation, and production of commercial devices using the same components to speed development time and improve quality. Yeah, and I think it's a combination of test and also, I would say, prototyping needs. And so when we work with folks, like I showed in my keynote, work with Samsung, work with Nokia, and many different universities, there's this huge race right now towards figuring out what exactly is 5G. And as figuring out what 5G is, basically which candidate technologies can meet the goals that have been laid out by the community for 5G. And that requires real-time prototyping to prove out the techniques in the real world. So it's the same technology that we use to measure, characterize, and test things that are being used to create these real-world prototypes of 5G systems. The Nokia system, for example, is a full 10 gigabit per second over-the-air link operating at 73 gigahertz. Yeah, millimeter wave is a really fascinating emerging space. It's very desirable because we have large chunks of unused spectrum, and the goal is to have 2 gigahertz of bandwidth for 5G, and the only place to get that is at very high frequencies. There's a lot of different bands being explored in millimeter wave, and no one quite knows which one's going to prove to be the most viable, most efficient from a cost to performance point of view. So what we're doing is we've created a platform that allows different millimeter wave front ends for creating these prototyping systems and measurement systems. So you're not locked into any particular frequency. You can do a prototype at 38 gig, at 24 gig, 60 gig, 73, and the various other bands that are being explored in millimeter wave. Yeah, MIMO is another one of the major vectors of innovation for 5G. I always tell people we don't know exactly what 5G is going to be, but we know it's going to be a collection of these different technologies, and MIMO is one of them. We're looking at things like massive MIMO configurations. I shared a prototype system from Lund University that's 100 antennas, but it uses software-defined radio technology behind each antenna so that you can try different types of modulation, diversity techniques, and see what the effect is on the overall signal. So MIMO is a big area of exploration today. Absolutely, this is a key question. I mean, I think if you look at the history of telecommunications and wireless technology in particular, it's been mainly about increasing bandwidth. And 5G is also about increasing bandwidth to be able to do instantaneous rates of 10 gigabits per second. But it's also about really meeting these new challenges faced by IoT devices. Massive numbers of devices, so a huge density of wireless sensors, for example. And then it's about ultra reliability applications, what I think of as the industrial Internet of Things, or machine to machine, connecting vehicle to vehicle, vehicle to infrastructure, medical applications, power applications and infrastructure. So really those areas are driving the technology to serve not just increased bandwidth, but these different types of applications driven by what we call the IoT. Absolutely. I showed at the keynote today that we're really close to approaching the pivotal point of 5G when these different technology candidates coalesce into an actual standard. And that's going to happen in the next couple of years. As you said, deployments are going to happen 2018, 2020, 2021. You'll start to see a lot more mainstream deployments. But the actual standardization of the technology will happen over the next couple of years. So now is the critical point where those prototypes and those candidate technologies have to be vetted out, so we decide which millimeter wave frequencies, which type of MIMO configurations, which type of radio access technologies. 2016 is going to be a big pivotal year for that. It's a lot of interesting things. Of course, these trends and pressures of the applications we want to serve, they exist today. And there's continuous evolution on LTE. So things like M2M, there's an M2M variant on LTE to serve these applications with lower data bandwidth, but lots of sensors or lots of connection points, and high battery life is a key requirement. That's an important area. Another real important area that's had a little bit of controversy lately is coexistence. LTE coexisting with Wi-Fi networks and actually handling traffic over Wi-Fi. I think that's an important area, and as we look forward to proving that out now, that's going to be an important component of 5G as well. 5G systems will dynamically use multiple different radio access technologies, including Wi-Fi and future versions of Wi-Fi like Wi-Fi AD, which is the 60 gigahertz band. Yeah, this is an area where I think the complexity of these systems and what it takes to actually design and test such highly complex systems is really at the forefront. I mean, the technologies you asked me about are all being discussed here, creating power amplifiers that can deal with massive MIMO configurations and millimeter wave, being able to support these high data bandwidths but efficiently so that we can have massively deployed systems. So these are the areas that folks here at Radio Wireless Week are the engineers that are creating the innovation that's going to enable these 5G networks in the future.
That was a great endpoint, but if there's anything else you'd like to address?
Sure. I mean, I think an enabling technology that NI is a big believer in is a common platform-based approach to use the same hardware and software technology to prove out a prototype, to take that prototype into a characterization and validation with the same measurement system, and then ultimately to use those same components to test the device as it's being produced. And that enables a lower cost and much faster time to market for complex systems.